That brings me to Proclidia marginata, the wasp that I study. And the reason why I study this wasp is it is considered to be in between solitary and social. These wasps can be completely solitary. A single wasp can build a nest, lay eggs, and guard the eggs till they become larvae. When they become larvae, she can go out and bring food and feed these larvae, and they wait for them to become pupae, and then she guards the pupae till they come out as adults. She can bring her offspring into adulthood without the help of any other wasp. So they can lead a solitary life. But most individuals prefer to live in groups where they work together, but only one individual lays eggs. So in all of these wasps, there's only one individual who lays eggs. Everybody else works for the rest of the group. So we call that individual the queen, except that unlike in honeybees, unlike in ants, unlike in termites, you cannot find out who she is. She looks like everybody else. In fact, she is one of everybody else. Almost anybody here can become the queen. Any individual, by the time she becomes an adult, she can either be a worker or she can be a queen. She has both these possibilities. And many individuals change their role from one to the other. And as you can imagine, that makes the system much more interesting for us to study. In the case of ants and honeybees, when a larva is very, very young, she is given some special food and she becomes a queen. Whereas here, every adult can become a queen and they have to fight it out. And as human beings, we of course find this system much more interesting to study. People have studied such species are called primitively social. That is, when the queen becomes enlarged, different, and fixed, we call it advanced social. Whereas when everybody is equal, anybody can become a queen, we consider these as primitively social. So this is a primitive insect society, a primitive wasp society. Now people have studied other such primitive societies, particularly in North America, to some extent in Europe. And the general finding is that in such primitive societies, the queen is very aggressive. And she uses physical aggression. She bites and she chases and she harasses the individual basically. And she uses this aggression both to prevent the others from becoming queens and challenging her, but also to prevent them from becoming lazy, to make them work. This is the general picture of such wasps. So when we began to study these, what we did was we said, let us not be biased by what people have found in other species. Let us also not be biased by the fact that this individual was seen to lay eggs. As far as we can make out, everybody looks identical. Let us consider them as wasps. Let us forget about who is queen, who is worker, and let's do as objective an analysis of the system as possible. So what we did, we marked each of these wasps with little spots of color change so that you can recognize everybody as an individual. And then we studied their behavior for long periods of time, and we converted their behaviors into numerical data. Behaviors which last a long period of time. We computed what we call time activity budgets. That is, we computed how much time does each wasp spend doing each kind of behavior. So 10% sitting, 5% fighting, 15% foraging, whatever. So we had a budget of the entire time for every wasp. And some behaviors are very, very short. You cannot calculate the time because it would be 0.001%. Those we said how many times per hour. Per hour, how many times does a wasp bite another wasp? So we have two kinds of numerical data. And then we subjected this numerical data to multivariate statistical analysis, basically to ask, is there a pattern? Does everybody do everything equally? No. It seems unequal. But is it random or is there a pattern? So we subject this data to multivariate statistics and do what is called cluster analysis. And when we did that, we found to our great surprise that you can actually classify the wasps in a colony into three groups, into three kinds of wasps. Now all of these wasps are morphologically identical, so there are no morphological castes. So we call these behavioral castes. And we name these groups as sitters, fighters, and foragers because these wasps, the most characteristic thing about these wasps is that they were aggressive. The most characteristic thing about these wasps is that they were aggressive. And the most characteristic thing about this group is that they were hard outside the nest. But this classification was not based on being lazy and being aggressive and working hard. It was based on taking all the behaviors simultaneously But then, to give them a name, you choose, of course, the most important name. So there are these three groups of wasps. This I call behavioral class differentiation. Now we said, let us try to retrospectively go and ask, where is the queen in this system? We didn't start by saying this is the queen. Now we can ask, where is the queen? And common sense suggested to us that the queen must be in this group, because queens are very aggressive and they use aggression to do what? To remain as queens, to prevent others from becoming queens, to make them work. So we said, surely the queens must be this. And it was nice that we began without having this bias as smooth queens. And then, of course, we found, to our great surprise, no, queens are not in this group. In fact, the queens are lazy. They are in this group. So we said something is wrong. So we said, let's go and study another colony, and let's go and study another colony. Colony after colony, the queens are sitters. Now, does this mean that there is no aggression in this species? Maybe this species is a very mild species. Answer is no. There is aggression. You can record the aggression, and using this aggression, you can construct a social hierarchy. Many animals you can do this. It's called a dominance hierarchy. You have an alpha individual, a beta individual. You can record the aggression. You can construct a similar hierarchy. You can see here there is a hierarchy, but unlike in other species, the queen is not number one. It's not the alpha individual, which is what you expect in other species. The queen, in this particular case, is in position 9. In some colonies, she can be at the bottom of the hierarchy. In some colonies, she can be completely outside the system. So this made the system much more interesting. And we asked, so the first question we asked was, how is the queen different from others? And the answer is that Raghavendra queen is a non-aggressive and non-interactive, we say meek and docile setter. Now this finding, of course, opened up the question, namely, if the queen is such a meek and docile setter, how does she become a queen? Why should everybody accept her as a queen? In other species, she is the most aggressive individual, and others have no choice but to say, okay, you are the queen. Why should we accept her? Now, in order to answer this question, we realized that just observation was not enough. We have to do an experiment. So the experiment we did was we studied a normal colony with the queen, and then we experimentally removed the queen, and we studied the rest of the colony. Now we use a very nice term for a colony without a queen. We call it an orphan. It's an orphan colony. So we studied the orphan colony, and then we realized that after you study the orphan colony, you can actually put the queen back into the colony, and you can study the colony again. And when we did this, we found something very, very spectacular. This species is not devoid of aggression. It has a little bit of aggression, like other species. But the moment you remove the queen, it becomes extremely violent. It becomes extremely aggressive. The level of aggression in the colony goes up 10, 20, 30 times as soon as you remove it. Even more surprising, all of this new aggression is shown as one word becomes extremely aggressive. Put the queen back, she will go back. Remove the queen, she becomes hyper-aggressive. If you don't put the queen back, she will become extreme. It will take about a week, during which she will develop her ovaries, be ready to lay eggs, and she will lose her aggression. Because the queen is not supposed to be aggressive. So this individual, after you remove the queen, before she actually becomes the next queen, we call her the potential. A queen is not supposed to be aggressive, but a potential queen is hyper-aggressive. But what's interesting, you put the queen back, and she will go back to work. She will drop her aggression, she will go back to work. Don't put the queen back, she will drop her aggression gradually within a week, start laying eggs, and become a respectable, peaceful, lazy queen. We study a normal colony, remove the queen, study an orphan colony, put the queen back, and study something. So we do these experiments over 3 different years, colony after colony. We've done this for more than 50 colonies.